can be broadly broken down into three main parts: classical physics, quantum physics, and relativity. We'll start with classical physics, and a good person to start with is Isaac Newton. His laws of motion describe how everything made of matter moves about, and his law of universal gravitation tied together the motion of planets in the sky with the falling of objects on Earth into one elegant and general description. He also invented calculus, a supremely powerful mathematical tool which has been used over the centuries to drive new physics. Calculus is really a part of mathematics, but physics and mathematics are inseparable. Maths is the language of physics, and you can imagine it like the bedrock that the world of physics is built from. Newton also made strides in the field of optics, which is the physics of light and how it travels through different materials. It explains refraction seen in prisms and lenses, which are used to focus light in telescopes, microscopes, and cameras. Telescopes enabled us to peer into the depths of space and observe the wild array of objects there, and developed astrophysics and cosmology. Optics is closely related to the theory of waves, which is basically how energy can travel through disturbances of a medium, like ripples on the surface of a pond or sound through the air. Light doesn't need a medium to travel through. It can travel through the vacuum of space, but it still follows the same principles as all waves, namely reflection, refraction, and diffraction. This leads us to electromagnetism, the description of magnets, electricity, or more generally, electric and magnetic fields. It was a physicist called James Clerk Maxwell who discovered that these are two aspects of the same thing and derived the wonderfully elegant rules of electromagnetism and theorized that light was an electromagnetic wave. Electromagnetism also explains all of electricity. Jumping back a little bit, classical mechanics is related to Newton's laws and covers the properties and motion of solid objects, how they move when forces hit them, and what happens when they are joined together, like in gears or in buildings or bridges. Fluid mechanics is the description of flows of liquids and gases. Using fluid mechanics, you can work out how much lift is generated from an aeroplane's wing or how aerodynamic a car is. Fluid mechanics is notoriously difficult, mostly because the motions of tiny things like molecules get really complicated really fast, which leads us to chaos theory. Chaos theory is the description of large, complex systems and how small differences in initial conditions can lead to very different final outcomes. Thermodynamics is the description of energy and how it passes from one form to another. It also